by ratio test, a series converges if the limit of S sub n plus 1 of S sub n is less than 1 as n approaches infinity. So the series will converge if the limit so all that we need to do is we need to find the expression for we need to focus on this bit. Okay, we need to focus on this bit. Then we can be able to find what values of x will make this series to converge. Now let me start from what you know. So we usually start by finding S sub n when you want to use the ratio test. It's usually easier that way. So S sub n is 2 to the power n over nx to the power n, and S sub n plus 1 will be 2 to the power n plus 1 over n plus 1 multiplied by x to the power n plus 1. Now that we have that, we can go ahead and plug this stuff in the ratio test. So in this expression for the ratio test, so the limit as n approaches infinity of this bit should be less than 1. So which bit? 2 to the power n plus 1 over n plus 1 x to the power n plus 1 divided by 2 to the power n over n x to the power n. All right. Now this will simplify to the limit as n approaches infinity of the absolute value of 2 to the power n plus 1 over n plus 1 x to the power n plus 1 multiplied by n x to the power n over 2 to the power n. All right. Now, what I'm going to do is to try and reorganize this expression by putting things that I can simplify together. So I'll end up with 2 n plus 1 over 2 to the power n multiplied by n over n plus 1 multiplied by x to the power n over x to the power n plus 1. Now this will simplify to 2 multiplied by n over n plus 1 multiplied by 1 over x, which will simplify to the limit as n approaches infinity of absolute value of 2 over x multiplied by n over n plus 1. Now x here is a dummy variable because x can take any value. All right, here you're finding it's, so we can take x as a constant. All right, it's just a dummy variable here. X can be any number. All right, and you're trying to find what values of x will this series converge anyway. So x is a constant because you're finding the limit as n approaches infinity. So what I'll end up with is take those things 2 and x out, but we're going to take the absolute value of x out. The limit as n approaches infinity of n over n plus 1. All right. Now we are saying that so that's expression for the limit of absolute value of s sub n plus 1 over a sub n. But you're saying this series will converge if this limit is less than 1. All right? So the series converges if this series converges if 2 over absolute value of x. And by the way, this will be equal to 2 over absolute value of x, by the way, all right, by LHR, all right? So that will be because the limits of n over n plus 1 by L'Hopital's is 1. So we end up with that. So this series converges if 2 over absolute value of x is less than 1. All right? It's less than 1. So what I'm going to do is to try and find what values of x will make this guy to converge. So we can simplify this. Remember, absolute value of x is positive, so you can just multiply by. So what we'll end up with is 2 is less than absolute value of x, or absolute value of x is greater than 2. All right? What that means is, you know, the absolute value function. You know, suppose it's this one here. Okay. So this bit is yeah. All right. Let me write it in this side. So this is f of x is equals to absolute value of x, and we have it here now. And suppose we have here this is x is equals to 2. Sorry, y is equals to 2, right? Y is equals to 2 there. And we're trying to find values of x where absolute value of x is greater than 2. And now absolute value of x is greater than 2 on this side. Basically on this side. For this value, let me use a different color. Maybe that one. On this side. All right, and on this side. Now here the values of x are 2 and negative 2. All right. So what I'm basically trying to say here is this is kind of a geometrical representation of this, but that will be when x is less than negative 2. Right here. When x is less than negative 2, or when x is greater than 2. Now, another thing that I want just to introduce here is we have to check these endpoints, right? So check the endpoints. Now, what I mean by that is sometimes the endpoints may converge or may not converge, all right? So sometimes the endpoints, all right, sometimes they can converge. All right. So the endpoints sometimes they can converge. So we need to find out. We need to check. How do we check? By just plugging in those endpoints. All right. So at x is equal to 2, we can start with that one. Our series will become we'll have the sum of n is equals to 1 to infinity of 2 to the power n over n multiplied by 2 to the power n, which simplifies to because these guys will cancel, right? So this simplifies to 1 over n, which diverges. by p-series test. All right. And so, which means that x is equals to 2 is not inclusive, all right, in that interval of convergence. And at x is equals to -2, we can check that as well. So our series will be 2 to the power n over n multiplied by -2 to the power n, which will be equal to, you just plug in whatever x is into the original series. All right, that one there, just plug it in. So what we'll end up with is sum from n is equals to 1 to infinity of, I'll break this up, so I'll have 2 to the power n over n multiplied by -1 to the power n multiplied by 2 to the power n. All right, because -1 to the power n multiplied by 2 to the power n is same as -2 to the power n. And then this will cancel. Okay, so what I'll end up with is a p-series. Sorry, an alternating series test. So I'll end up with an alternating series test. So I'll end up with an alternating series, not alternating series test. Tend to say a lot of words, still I get confused with those. So end up with that, and then this is multiplied by 1 over n. Okay, this can be written as, I'll end up simplifying them just to make them much better for you. So this will be n is equals to 1 to infinity, -1 to power 1 minus n. So this is much better, you know. And you can, just by looking at this, this is an alternating series, alternating series, and it converges by p-series test. I don't have to work that out. You know, if you can check S sub n plus 1 is less than S sub n, and another thing that you need to check is the limit of S sub n as n approaches infinity is equals to 0. So it meets that condition. So we can say that this series converges by p-series test. All right. So converges by p-series test. So after all those stories, now we can conclude and say that our conclusion is the interval of convergence or the convergence interval of this series. So convergence interval of this series is x is less than or equal to 2, not 2, less than or equal to -2, or x is greater than 2. Now, and you can see that, you know, one of the points is at x is equals to 2, the series is converging. At x equals -2, the series is converging, but at x is equals to 2, it's not converging. So, you know, that's why it